What is CPM? Hey everyone, I'm Nick. I'm from RadView Detection, and today we're going to be covering what is CPM. So we have a bit of an analogy set up, and we also have some detectors to demonstrate. So let's go ahead and power on our detectors. So here we have the AlphaHound, and here we have the GMC 600. So what is CPM? So let's break it down. C stands for counts. That's counts. P is per, and then M is minutes. So counts per minute or counts per unit time. So let's cover what that means. So a count is anything that interacts, an ionizing particle that interacts with the sensor inside of these detectors. So every single time a particle interacts with either of these detectors, you get a count. Well, now what does per minute mean? Well, that's how many did you get in 1 minute? So you can see here, AlphaHound is currently getting 240 counts per minute. So an ionizing particle interacts with the detectors around 240, 300 times per minute. The GMC 600 over here, we have 44 counts per minute. So again, that's counts per unit time. And that's how many times particles interact. So even though right now they're both in the same environment, we have the same background radiation here, the counts per minute are different by almost a factor of 10. So why is that? Why is the count rate discrepancy there? So I want to pull back, come away from the scintillators and the GM tubes, and just look at fishermen fishing. So in this demonstration, we're going to use fish to resemble our radiation, and we're going to use our fishermen and their nets to represent sensors or detectors. So you can see here we have 3 different size nets. So we have a small, medium, and a large net, and these guys go fishing. So let's say this guy catches 1 fish, and the guy with the medium-sized net catches 2, and the guy with the largest net, he can scoop up more fish, so he catches 3 fish. So now you can see there's a bit of a problem, because if I ask these fishermen, how many fish did you catch? This guy is going to say, I caught 1 fish. This fisherman will say, you got 2. And this one will say, I caught 3 fish. There's 3 fish in this lake. There's 2 fish in this lake. There's 1 fish in the lake. These are all different numbers. Even though they're in the same lake, they're fishing for the same fish, they're different numbers. Well, that's because they have different size nets. This guy has a bigger net, so he's catching more fish. He's detecting more interactions, more counts per minute. So this is why counts per minute can be a little confusing. If you're using different size detectors, different size nets, you'll get different results from the exact same source of, radiation or fish in this example. So we use it because it's a relative term. It's not relative to other devices, but it is relative to itself. So if you can say on Saturday, let's say this guy caught 3 fish, and then on Sunday, he caught 6 fish. He would say, Sunday, I caught 2 times the amount of fish. So he'd say, Sunday has twice as many fish as Saturday does. And so it's relative to this guy. And likewise, again, fish still in the water here. If this guy caught 1 fish on Saturday, on Sunday, he might catch 2 fish. And so he caught 2 fish on Sunday, and he says there's twice as many fish on Sunday. So these guys both agree, even though they had a different amount of fish, they would both say it's twice as many fish on Sunday. So next, what I want to do is bring these instruments back in. So you can see the background count rates here. We have around 200 counts per minute on AlphaHound right now, and around 43 counts per minute on the GMC 600. So if we go ahead and introduce a radioactive source, and again, these are our background numbers. So I'm going to go ahead and introduce a europium-152 check source here. And you can see both the detectors pick it up. So this is a 1 microcurie source, and we're looking at the relative change. Again, our theoretical how many fish you catch on Saturday is background, and then how many fish you catch on Sunday is what we're measuring. So now you can see, if we do all the math, the GMC 600 ends up around 6 times above background right now, and AlphaHound's pretty close too. It's around 6 times background. So even though AlphaHound says 1500 counts per minute because it has a bigger net, the GMC 600 says we have 159 counts per minute. So even though those numbers are around 10 times more difference, the relative increase is the same, around 6 to 7 times more radiation than background. So we can use it in a relative sense. You could say it's 10 times background or it's 100 times background, but you can't say 160 counts per minute on the GMC 600 is the same as 160 counts per minute on AlphaHound, because the AlphaHound is more sensitive, has a bigger net, catches more fish. So hopefully that helped to clear some things up. Again, I get this email all the time on, my AlphaHound is over responding, or is this a dangerous amount of CPM? Again, please understand that AlphaHound is more sensitive, and same with bigger detectors. There's much larger detectors that'll catch much larger fish. So if you want to compare the two, make sure you're stating what instrument you measured it with, or at least how many times above background that normally is for you. This is AlphaHound. I build this detector. It is an alpha, beta, gamma detector that can detect and separate all 3 particle types. So you can do your alpha, beta, gamma detection and separation. Next up, we're going to do what is dose rate, which you can kind of think of as different sized fish. Can the detector tell what size fish you're catching? That'll be in our next video. If you guys have any video suggestions, drop them in the comments. I'll try to make as many videos as I can, hopefully around 1 per week. This has been RadView Nick. I will catch you guys in the next one.